so continuing with the Six Flags theme that we've created for our unit, I'm going to be talking about the simple independent events, and what I'm looking for from you guys is to kind of help me make sure that I am doing a proper lesson for the students and I'm not overthinking things or missing something or, you know, maybe getting some ideas from you guys. So my first question that I have is, what do you think? Is this a good visual, or should I just kind of stick with a more lighter background and not have the numbers, or is this okay to see?
Yeah.
Yeah, that's fine.
Okay. So going on to the next. So I haven't added any animations because I wanted to get your feedback before I started adding too many animations in, because I don't want to distract the students, but I still want to engage the students. So some of the ideas I had was only bringing in probability, and like one of you guys mentioned earlier, let the students give me the answer for the definition. I think that was your idea, Monique. And then after the students have had a chance to say something, oh, probability is this, this, and this, I'll actually put it up here and then have it here in like a numerical. I know that's not numerical, but what it would actually look like as a formula or some type of plug-in for them to have so that they can write it down. And have all this come in next after just have a blank slide for probability. So here, I'm going to give an example for using the numerical formula or plug-in that we have here. And I'm going to say jelly beans. I have it on the next slide. I have a picture of jelly beans. So we're going to look for the probability of drawing a green jelly bean. And I'm just going to use the picture instead of anything hands-on for right now. So here's the picture. And what I plan on doing is having each one of these come in. So how many green jelly beans? And everybody will shout, hopefully 6. Same here. How many total jelly beans? 18. And then lastly do the same thing here. And then here I'll explain, I'll have the 1/3 come in last, and I'll explain that we have to reduce the fraction, which I'm hoping most of the students will know how to reduce fractions, and especially after yours, Ashley, they should understand that we have to reduce to get down to the actual answer. So then I'll go into what does it mean, and I'll not add this up here, I'll have just what does this mean, and I'll let the students answer the question. So what do you think, Monique? How do you think we can use what we just found out to answer an experiment of finding how many green jelly beans? And I'll just let random students answer, and hopefully I'll have students engaged. If I don't, I will call out to somebody and say, hey, Steve, what do you think? And then I'll have this pop up on the screen so the students can write it down, and then have a more visual, because I know that some students are not all auditory learners, they like visual, so they'll have the answer here. I was a little iffy on how to do a visual for this, so if this is confusing, let me know. Basically what I was trying to say is, will it happen? So is it going to happen, maybe happen, or not happen at all? So I'm using the cylinders to represent 100%, 50%, and 0%. More likely to happen, less likely to happen. Is this clear?
Fairly. Only thing I would say is maybe it doesn't have to be like a 3D representation. Like you
So
can
take the 3D
you can just do it
aspect
with
out?
a bar graph, something that they'll be more familiar with.
Okay.
I guess. But yeah, that's still like to us. Yeah, we definitely that's pretty. That's,
So the graph is a good, the chart is a good idea, just remove the 3D function.
yeah.
And are you going to be explaining this?
Yes.
Breaking it down? Okay.
Yes. And I might, I was actually thinking of doing it one at a time, bringing it in one at a time and explaining what this cylinder means, bringing in this cylinder and so on and so forth, and then bringing in this part last. So it's not all thrown up there at one time. So then I'm going to explain that probability can only be 0 to 100%. It can't be 110%, 120%. I know that that is something that people say all the time, but to explain and clarify that that is just a saying that people use. So, and there again, I'll engage the students in this question. Then I have another example of using cards. I'm not going to bring in a full deck of cards, but I'm going to bring in just a couple of cards, and I'll have some cards that I'll show and I'll have. just to get away from the PowerPoint, instead of adding it to the PowerPoint, I wanna just step away from the PowerPoint for a little bit and have something that they can look at me instead of looking at the screen. Then I'll have the answer, but once again, I'll bring it in one at a time. And then I'll ask them to do this one. I'm gonna have worksheet, but they're gonna follow along in my presentation, and everything will be mapped out for them. So on the worksheet, when we get to this part, they're gonna answer this question on their own. And then they're gonna answer this question on their own, but then we're gonna go back to the chart, or I'm sorry, no we're not. We're gonna go through the answer first. I'll give them the answers, but once again, one at a time. And then we're gonna go to the chart and try to compare. I was gonna bring this in, but to me it still seems confusing, and I didn't know how to do this, and they understand what exactly is being done. So to pull out the red queen out of a choice of 12 cards was 16.7%, which lies here, which falls into this bracket of will definitely not happen, because it kind of fills up more of this space than any other space on the board or on the chart. For the 50% of pulling a red card out, it fills up more of this cylinder under the Y. It may happen or may not happen. So, and once again, I was going to bring the lines in one by one as I discuss. Is this a clear representation after I remove, because I am going to take the 3D out. Is that a good representation, or do you think I can do something a little bit?
Do you think that you can, like, actually do the 16% and 67%? Like, actually do it? So I think it might be confusing because we still have this 100 bar right here.
So remove the fillers and put the actual numbers in?
Well, we could do that, but like the cylinder itself, the 100% cylinder.
Oh, remove it.
Yeah, since we're only comparing the 67 and the 60.
Since it only matched with this cylinder, which is non-existent, but this cylinder and this cylinder, remove this cylinder.
Right, because that might confuse them.
Okay.
And then actually going ahead, because like the 16, they're like, well, there's nothing there. So then actually doing the 16 and doing the 67.
Oh, I see what you're saying. So actually have the cylinder come to here.
Yeah.
And actually have the cylinder come to 50. Got you. Yes. Okay. Then yeah, that makes sense. Okay. That'll clear it up for me there. And then I'll go into a verbal answer. So we have the visual answer. Now this is the verbal answer of why, and then explain that 50% is greater than 16.7%. And then I'm trying to find another example. I was gonna do the heads tails thing, but I know that Steve is gonna be talking about that in his, so I didn't wanna do too many things that the students would think is repetitive and get bored. So I wanna think of another creative example. So then I'll just have a recap and everything. And then I'll have some added notes, just some things that weren't covered that kind of should be covered. And then after this point, what I plan on doing is having, probably on the back of the worksheet that they had, going through the PowerPoint in the lesson, an actual activity, hands-on activity. I plan on bringing in something similar to the jelly beans, but I'm going to bring in M&Ms, little fun-sized packs of M&Ms, have the students grouped into fours, so that they can sit there as a group and they can pull random chances out. And I'm going to have on there little questions that kind of play in the whole Six Flags theme of maybe they're betting against their friends, like I bet you I can pull a red M&M out every time. So what is the probability that Steve really can pull out a red M&M every single time? So I'll have on try to connect with the same Six Flags theme, fun little games and activities that they can do for maybe 10 minutes just in the group, and then maybe a 5-minute discussion on what each group did and how they have taken the concept that they learned and actually applied it to not only a real life example, but also a physical example at their desk. So from there, any more suggestions or anything maybe I haven't covered?
Well, is it do they need to know what an independent event is?
Yes, and when you brought up vocabulary, I need to definitely add in the vocabulary of what an independent event is, because I know that Steve is gonna talk about compound,
Yeah.
which of course independent is just a single, one time doing something.
Okay, so how will you assess the lesson, and how will you find out if students have learned what you're trying to convey?
Well, after the lesson, I'm gonna take up the worksheets that each student will complete. Even though they're in a group, I'm gonna want individual work, so I'm gonna use that. I'm also gonna use the pre-assessment and the post-assessment to figure out how well they have learned everything in this unit, not only just this lesson. And I plan to record it in Excel and monitor which concept maybe they missed and understand, so that I can try my best to go back and maybe refresh it if I need to, either individually or as a group.
Okay.
Oh, my bad. I was thinking, maybe in my lesson, cause I'm gonna, like, I guess in my lesson I was gonna define events and like define what an event is and stuff like that. And maybe because they're gonna need to see, like, they're gonna have to be able to identify, like, okay, is this even independent? Like, okay, if I'm given this information, does this change the probability of what I was looking at it originally? So, I mean, I'm trying to figure out how to incorporate that with the.
Well, wouldn't we have already covered that in previous lessons?
I'm not sure.
So like Monique is doing day 2 of her lesson, I'm doing day 1 of my lesson. Maybe towards the end of your lesson, you had already covered that.
Okay.
So maybe we can go with the assumption that some of this stuff we don't need to get knee deep into it because we've already discovered it in previous lessons, or we'll cover it in following lessons.
And okay, so we have a few activities going on. So how can you make sure you budget the time?
Okay, so with my lecture, I want to keep it as minimal as possible. So I plan to practice my lesson, make sure it's down to, however, once I go through my lesson plan and map out my time. I plan to stick to my time and have a clock, watch what I'm doing, and then when I flip it over to the classroom, I want them to also be engaged with their time and what they're doing. So I want them to know, okay, we have 15 minutes to do this as a class. I'll give you warnings, but let's try to work as efficiently as possible to get through everything. So I'm gonna try to monitor with clocks and.
Okay. So what about the room arrangement and the materials? Like, how will that enable the learning in your lesson?
I'm gonna use groups of 4 so that I can have the slower learners working with the more advanced learners, or the challenged learners working with the unchallenged learners, so that everybody in the group can kind of work and help each other and be all engaged. So the group of 4 should help. And then the materials, actually having something to play with that hopefully they won't eat as they're playing with it. Hopefully that will also be something cool and fun that they get to play with. And I will bring in extra ones so that they can eat, so they're not tempted to eat the test samples. And I'm bringing hand sanitizer so that as soon as I clean hands.
All right. And what do you think will be the critical moment or turning point in your lesson?
I think turning it over to the students to actually now, okay, so we saw how to do the jelly beans, we saw how to do the cards and other examples, we had our tree diagrams, and we've had all this other stuff with Six Flags. Ooh, I wanna keep digging into this. I wanna now give me my chance to do this. How can me and my friends do this now?
Okay.
Everything's good. Looks good.
Alright.
Anybody else have anything for Adrian? No? All
Thank you,
right.
guys.
Well, take this to a close.